With interest rates at historic lows, putting your money to work is harder than ever. Yield Street.
All right, we're going to test our audio here in a minute just to see how everything's going. And if everything's going well, we'll go ahead and get started here. Throw up a little bit more of the audio here so you can hear the music while I'm doing this. Right there. Let's go right there. All right, we're going to test our audio. I'm going to mute myself here real quick. All right, throw up a little bit there. There we go. I want to be able to hear the audio here, the music in the background while we're doing what we're doing. Okay, so welcome everyone to another episode, another lesson. Code Black here. Let me mute my phone over here. Mute that over there. Alrighty. So, as always, thank everyone for looking at these particular lessons. Hope you get anything, something out of them. I'm shooting today from the wife's office here, former room of our eldest. She's out in college right now, so Mama reclaimed her time. So as always, go over and check the Code Black Facebook page. You can also check out Code Black's website. I'll throw a link in the description of the video here after the live stream's over. I want to cut over there right now. And as always, this is a safe space, and it's also a place where we help collaborate. I am not the end all be all of all of this, just a guy trying to share some knowledge. So today we're going to talk about hashing. What is hashing? What is it for? What's it used for? All that good stuff. So we had a conversation earlier today on the Code Black on the Zoom, and it was about cryptocurrency and NFTs, which are non-fungible tokens. And again, I'm no end-all be-all of NFTs and crypto, but I do have a basic knowledge of the technology behind it. And to me, it's easier to understand a process when you understand the technology behind said process. So today we're going to talk a little bit about crypto and cryptocurrency, not cryptocurrency, but hashing. I'm sorry, hashing. So, and then maybe in another lesson, we'll talk a bit about blockchaining and all that good stuff. So, what is hashing? Well, let me shift my screen here. There we go. Hopefully you can see that. What is cryptocurrency? What is, I keep saying cryptocurrency. It's a habit. What is hashing? What is hashing? Well, hashing is basically taking a value and turning it into something else. I went to the Simply Learn website here, and I looked up this particular lesson here, and there's a multitude of different, because it talks about in this particular, it's a cybersecurity course that they have here. And one of the things that they talk about in this particular part of the course is the SHA 256 algorithm. What is it? What does it stand for? What is hashing? Well, to understand hashing, you have to understand the algorithm. You have to understand hashing first. So what is hashing? Hashing, if you look at this nice little graphic they've got here, you basically are taking a piece of information, scrambling it up, and turning it into something else that can't be converted back into what it was before. A great example of that, if you look here, it says password 123. There's a function that comes over here and turns that password, that string of data, into a value or a digest or a hashed value. And so the function takes your plain text and turns it into a hash. Now, keep this in mind, and this is where a lot of people get mixed up at cryptology and the meaning of this type of logic here. Hashing is designed to be a one-way trip. Encryption is different from hashing, okay? Encrypting something means that you have a key, you take your key, and that tells you how to turn it into something else and to turn it back into what you had it as before. You take that key, and then what you do is you take your value using that key and you encrypt that value. You can give the encryption key to another person, not the original key, but the encryption key just for that data. And then you can send them that encrypted value, and then they can turn around and take the key that you give them and turn that encrypted value into unencrypted data. That's encryption, and that is something that can be hacked. It can be broken into, not easily in some states. Usually, the point of failure is human nature in these instances, allowing individuals to have the encryption key by accident, or unencrypting data, or sending data in the open. Those are things that human beings mess up on and cause that information to get out there. So that's encryption. Hashing is slightly different. Hashing is you're taking data like we see up here. You're taking this data and you're turning it into something totally different without the mindset that I'm going to bring it back as something else. And so hashing is different because there's no way to, at least with the algorithm that's used now, there's no real good, easy way to break that, to turn that hash back into something else. The only way to do that is to brute force something, and I'll talk about that here in a little bit. So there's two applications or two things that you would use hashing for. First thing, and the more common thing, is what you do is you take a user password, you convert it into a hash, and you store it on a database somewhere or on a server somewhere. And then what happens is when that person logs in, it hashes what they put in there, and it compares the hash to the stored hash. And if they equal one another, then What happens is they are verified. If they don't match, then what happens is, like you can see here, that you can deny them access to your website. Okay. Now, the other reason that you would use a hash is for verifying the integrity of data. And that is where things like Bitcoin and other cryptocurrencies and NFTs use hashes. What they do is they use a hash and they take a bit of data and they turn it into a hash. And then what happens is you can send that, and then you can verify that it's a hash and that it's something that can be compared to. A great way to look at this is if you look at an NFT. An NFT can be a piece of data. Let's say it's a video. You take that video, you turn that video into an array of bytes, because it's just data, right? You can transform it from the video into a byte array of data. You take that byte array of data, you turn it into a hashed value, and then you take that hash value and you can use that hash value to verify whether or not what people are using is the actual current thing. I'm kind of going around on that one, but so that's how hashing kind of works in a nutshell. Now, what is the SHA 256? It's Secure Hash Algorithm 256. All that means is that your hash value is going to be 256 bytes long of data. There's a 64-bit hash, there's a 128-bit hash, there's 256, there's 512. It just kind of doubles in size when it comes to kind of the memory. So what are the characteristics of the SHA-256? That's what I call it. The length of the message, the digest length, and it's irreversible. So it should be, the length of the clear text should be less than 264 bits, okay? And the reason why is because you want it to be random. And the more stuff you stick in there, the less random it's going to be. Then the digest length of the hash has to be 256 bytes in that SHA-256, 512, and so on and so forth. Okay, now the larger it is, the more data, the longer it's going to take. Okay, then the most important thing about a hash is they are irreversible. So if I stuck my name is Alex into a hash, I can't take that hash and turn around and unhash it and then find out what it says. The only way to validate that is to have the original text and turn that into a hash and then compare the two. Okay, so we're not going to get into the makeup of 256 algorithm. We're going to kind of forego that one. But what I wanted to do is I wanted to go ahead and let's just build a very quick example of a hash algorithm. Very bare bones basic. It's a little insecure, but it'll kind of get a point across. I'm just going to come up here and I'm going to create a new project. And I'm going to just make a console application in .NET Core. And we'll just call this, instead of calling it Codeback Crypto, we're going to call this Live Crypto. We'll call this Live Crypto. Okay. Well, it helps if I have an actual folder here. Okay, this is the folder I need to select. It's late. Okay, this is going to be Live Crypto app. Let's call it that. Okay, next, we're going to use a .NET 5.0 framework, as always, until the next one comes out. which I think it's coming out. I think 6. They actually had a thing last week in Microsoft for .NET, and I believe it's coming out. All right, so let's hide our Test Explorer real quick and come in here. Now, let's go ahead and do a little cleaning here. Clean this out here. So what I'm going to do is I'm first going to determine what I want to encrypt, or not encrypt, what I want to hash, okay? So let's just create a very simple hash here, or a couple of strings here. Because what I want to do is I want to flip through them. And equals new list of string. And I need to put my using up here, using system.collections generic. And I'm going to get rid of this string array here because I'm not passing any string stuff here. All right. And in my list of strings, just make a couple of strings here. So the first string is going to be A, B, C, D, 1, 2, 3, 4, 5. And the second string is A, B, C, F, 1, 2, 3, 4, 5. Now, the reason why I did that is because I'm going to show you what happens when you change. Actually, let's make them the same for right now. There we go. I'm going to show you what happens when you have the same information, and then what happens if you change it. This is the beauty of hashing. Okay, so let's go ahead and create a couple of strings here. I'm going to create a string called hash data. Alrighty. And we're going to create a string called previous hashed data. Okay. Now, what I want to do is I'm going to loop through, create a loop, because what I want to do is I want to print out the hash for each of my list, items here. So for each var, let's do it the right way, string list, string data in args. Okay, so what that's going to do is it's going to loop through each of these iterations of strings. And then what I want to do is I want to do my hashing here. Next, I want to compare my hash to the previous hash. And if it's equal, give one message. If not, give another. All right. So the first thing we have to do here is we have to bring in the correct library that will allow us to do the hashing. And that one is called using system, security, cryptography, I should say. And we need this one too because we're going to have to encode this to a byte array. Okay. So next, what we need to do is we're going to create a separate method for this. And I'm going to pass in the original data. I'm going to pass in the hash the data, and I'm going to pass in the previous hash. Okay, because what this is going to do, it's going to do my, actually, let's do it this way. We're going to make that a string here momentarily. Make this a string. And make this a void. And we're going to call this check hashes. All right. So what's going to happen is, in this particular one here, I'm going to actually do my hashing here. I need one more. We need to pass in our string. We'll call this plain text. Like that. Okay. So what this is going to do, just real quick so I can get rid of these. What this is going to do, what this method does, this method is to create the 256 hash string. Okay. So in here, we're going to take our plain text and we're going to actually use the 256 algorithm class is what we're going to do. So we're going to say using 256. And if you look here, you can see there's a bunch of different ones in here for cryptography. I can say RSA in here, and there's RSA providers in there too. But we're going to use SHA 256. Equals 256.create. And what that does, if we hover over this, is it creates a default implementation of the 256 class. Now, if we kind of go to this 256 class and we go to the definition of this class, we can see it's an abstract class. So, what it does is it inherits from the hash algorithm class. So it's a static class, and it's a static abstract class, I should say. Well, let me say it again. The class is abstract, but the methods are static. So there's no need to use the new keyword to instantiate. So now the next thing we need to do, what this does is this creates the 256 hash here. And then what we're going to do is we're going to do the computation of the hash. Okay. Now, here's where some transformation stuff kind of happens. To do this, what you have to do is you have to turn whatever your data is into its simplest form, and that's byte data. It's just an array of bytes. And so, like, for example, you're messing with somebody texting me here. You're messing around with string data. So if you're just looking at ASCII data, right? Let's go back up and see what we have here. If I look at, if I go to my ASCII data here, let's see, ASCII table, ASCII table. And I look at the ASCII table. What we can do, make this a little bit bigger, is we can see what our bytes are going to be. So capital A, if we look in here for capital A, here's A right here. So the first byte of our byte array is going to be a 65. Okay. So let's actually do a little bit of logic here, and let's actually try to just turn this first one into a byte array just to see what we get back. Okay. I'm going to take data. Goes encoding that get bytes data, and I'm gonna put a breakpoint right here and click start, and I'm gonna debug this. And if we'd have 10 here and we look in this array of bytes, if you see here, our first byte is a 65. And let's kind of just let's do it this way. Actually, get rid of that. I'll just look at it down here. It's right here. So you can see we have 65. So we can go back to our ASCII list here. And if we look, it's A, B, C, D, 1, 2, 3, 4, 5. It's 65, 66, 67, 68. And then 1, 2, 3, 4, 5. And it'll be 1, 2, 3, 4, 5. And it says 50. 50 right here. Actually, I was in the wrong spot. 50, 51, 52, 53. And so 65, 67, 68, 49, which is a 1, 50, which is a 2, 51, 52, and 53, all the way up to 5. 1, 2, 3, 4, 5. So when you turn something into a byte array, that's basically what you're doing, is you're getting the bytes there. And you know, ASCII tables can be extended out and stuff. There's other for special characters and stuff like that. So I won't get into that. Okay, so close my thing here. Okay, so the next, so this actually obviously is doing what we're wanting it to do. So the next thing we need to do is we need to take our I'm trying to look at 3 screens here. I apologize. We need to take our and build our keep building our 256 hash value algo. Okay, and so now what we need to do is we need to take that data that we have, our string, and turn it into a byte array like we just did before. We're just going to call this SHA-256 hash. Compute. Oh, SHA-hash, Alex. Compute hash. And what we're going to do is we're going to do, and what this compute does is it takes a byte array and it turns it into another byte array. It takes your 8 characters, nine characters, how many characters we have, and it's going to turn it into a 256 byte array. Okay, that's the beauty again, that's one of the things that's cool about hashing, is no matter how small your hash is, it's always going to be 256 if you use this particular one. The bigger you need your hash to be, you use a different hash. Okay, so what we're going to do is we're going to take our encoding. Oh, goodness, Alex. UTF-8, get bytes. We're going to take our plain text and put it in there, which is going to give us a byte array. Now what we need to do is we can take that array and convert it to a string. And so to do that, we're going to have to take each byte, and what we're going to have to do is we're going to have to do a little bit of funkiness here. So we're going to create a string builder. Okay. We're going to do a for loop. We're going to start at the index of 0. We're going to get this for the bytes length, the length of the array. And then what we're going to do is we're going to string SB append each byte, the index of I, x2. Now, if you're wondering what this x2 is, what you can do is you can go to here. You can say x2 string right there, and what it does is it takes those and what it does is it takes that and it turns it into a standard numeric value string. So because you're dealing with bytes and ASCII characters and other characters, x2 right there, it's just hexadecimal, right? So like right here it says if you use x to produce a, b, c, d, e, f, and lowercase x to use a, b, c, d, e, f. Okay, I'm not going to get too much into that, but all right. So now what we can do is we can return our return type. Actually, I'm going to take the string builder and put it up there. And I'm going to say sb.toString like that. Oop. String. All right. Now, what's going to happen is I'm going to take that string method there, and I'm going to stick that into up here. So I'm going to say hashed data equals create, and it's going to be data, which is our string value here. It's gonna, because it's gonna loop through each of the values that we put in here. Okay, so now, as of right now, we've got enough to actually loop through a hash and see what we've got here. So I'm gonna put this on my debug there, and then I'm going to put this in a watch list there. It's already there actually. F11, 10. And I'll just go here. And here we have an actual hashed value. And so now our hash data is this value right here. So let's copy that. Let me stop that. I'm going to put this here. Okay. because that's going to be important when we're validating the hash. Okay, so we've got our hash value. So the next thing I want to do is I want to compare it to the previous value. And one of the easiest ways to do that is just do a really simple if conditional. And what's going to happen is I'm saying if my previous hash data is null or empty, then I'm going to skip setting my previous value to my hash value. That just kind of skips one, right? So I'm going to put previous hash data equals hash data. Something seems off about that. If string is null or empty, I need this to be not. Okay. So the first time through it skips that. Second time through it'll put that in there. And actually I need to stick this up above here like that. So every time it goes through, it takes what I just hashed and puts it into a previous field, and then it rehashes, and then it does a compare. All right, now I want to do my compare hash. If compare what I call it check hashes actually. And we're going to have previous and hashed. And I need to change that to a Boolean value. Boom. So what's going to happen is, I don't need that one. So I have the current hash. We'll call it current hash. And I'll call it previous hash. Okay, now, basically what I'm trying to do here, what I'm going to do is I'm going to check the two hashes, and if they equal one another, then I can output one thing. If not, then I output something else. If current hash equals previous hash, then what I want to do is return true, else return false. Okay, so what that does is it's going to check my hash, and if they equal one another, then I'm going to print what I need to print out. And so this is going to be output hashes. And I'm going to put in the plain text. What did I call it? Oh, no, I need to data. And then I'm going to have my hashed data and my previous hash. What do I do here? Previous hash data. Okay. Now, lastly, I'm going to say return string at format and say original. Well, I'll call it. We'll say pre-hash. Pre-hash. well, we'll just say hashes match. Something like that, right? Else, here, meaning that they don't match, then what I want to do is I want to say, yeah, hashes match. Let's say I want to just do something different here for my non-hatchings matching. Bad hashes. We'll call it bad hashes. And here I'm going to say string return hashes match. Return hatches hash error. And instead of using the @ symbol there, I'm going to string, use string interpolation. Hash error. Say original. And it's going to be original. And this is going to be hash. Current hash. It's going to be hash. And this is going to be previous hash. So this is just saying, hey, they don't match. Here and say, let's put bad hashes. Just put the same stuff in there. All right. And up here, we're going to put our there, and console, and say down here, equals, like that. And say like that. And then up here, just say checking hashes or something like that. Okay. And then we're going to put empty line in there. Copy that, paste that again one last time. Press any key to continue. Uh-oh. And all right. So now what that should have done is if we send this through, rebuild our logic first. I thought I brought my Get my water. So we rebuilt our logic in our project. So let's run it and see what happens here. Oops, sorry. Let's run that. And I'm just gonna let her ride the coattails here. Get rid of that breakpoint there. All right, so now if we look at our output window here, our first hash worked okay, and our second hash was wrong, and our output message is not quite right there. So let's do a little bit of logic here, looking into what we got going on here. Okay, so let's loop through. 10, check hashes, output message. Oh, I see what's going on there. There is no hash there. Okay. Let me think this through here. Okay, so this is just a matter of getting the right order here. So we have hash data. Oh, I know what I need to do. How do I want to do this? So what I need to do, this is algorithmic thinking, y'all. What I need to do is first I need to say, okay, I have nothing in my hash data or my previous hash. Okay. So then what I need to do is I need to say, okay, well, if I don't have a hash, previous hash data, string is null and empty, previous hash data equals, I might have that backwards. Let me see what happens here. Okay, so they're both equal to one another now. And that's going to come up false because they don't match one another. I don't need that to happen that time. If string equals that. I think I do have not an order there. Actually, I'm making this smarter than I'm working harder than I should be here. If it's null or empty, I probably should just do this instead of moving it in there. Say if previous hash data equals hash data. Then do that, else do this. Something like that. And then, because they equal one another, if they don't equal one another, then I need to check the hashes. put this up here. I think that's what I want to do there instead. Let's see if that does the trick. I think I'm missing something here in my algorithm, but let's see what happens here. So they don't equal. Probably use a counter instead too. It's probably easiest to do. That's probably the easier thing to do. If counter equals 0, then I want to take my hash data. Oop, hash data there. And then I'm going to put my previous hash data equals hash data. I think I can do it that way. Else, I'm going to just take this hash data and come down here. If previous hash equals that one, do that. Otherwise, actually, I can get rid of this right here. Okay. And counter. So, now let's try and run through this. Okay, so counter equals 0. Should set that there. Run my output message, which is nothing. Actually, let's put output message. Do it that way. That way we know we're going through the first one here. All right, so our hashes are equal to one another. Now we're going through the second time. We have a different hash now because it's now ABCD 1 2 3 4 5. And the hashes still match, and we're good to go. And I guess I could probably do what I'm doing here like that. That should work too. So that way my output messages match one another. And here's this right here. Okay. But it didn't do what I thought it was going. Oh, because they match. All right, so now let's take our hash and let's change it by 1 byte. Let's change that D to an E. Make it uppercase this time. So we'll do the second time. We're on the second hash. So now the hashes don't match. And if you notice, now we've got a hash match error here. can see we've got our current hash, starts with C74 and some change. So if I copy that, I'll show you the difference here. Copy that. And that is our first hash right here. Actually, and you'll notice that that's this one right here. So you can look at these and you can tell they're different just by looking at them. All right. This one starts with 355, and this is a completely different number in hash here. Completely different. There's nothing, these characters, they don't match one another, right? So this is, and it doesn't matter. I mean, I can change this to an X or a lowercase. Let's change it to a lowercase d. And because the bytes are different, again, getting back into the ASCII characters here, our ASCII table, and we go back and look, a lowercase d, which is a way over here, that is a 100 right there, not a 68. So if you go back to that logic that we looked at earlier with the byte array, it's going to change it into something different, and the math is going to be totally different. Okay, if I run through it this time, let me take that breakpoint off. Run through it this time. Here's this hash. Okay. So if I go back up, it's a completely different number. No matter how you change the data, if the data changes, the hash will always change. And the math involved to get to this number is astronomical. It's astronomical. You cannot take that hash and try to determine what it is. The only way to do that, unfortunately, and it can be done, but I mean, it's just a very difficult way to do it, because you'd have to start with the string that's very similar to the original string, and the math involved in that, the probability is just, it's huge. So this is what hashing is. And so if you take this knowledge of what hashes do and what they're for, then you can start to understand how non-fungible token NFTs and Bitcoin and blockchain, how it works. So today, again, we talked about hashes. Oh, and let me do this. So like, for example, let's say I wanted to create a table because I actually have a database over here that I can use. Let me close that down. Cancel that, cancel that. What's this here? Take my SQL server here. Okay. So let's say I have a table. Just gonna do it real quick. I'm gonna call it hash vowels, something like that, right? And we'll put in and varchar. Now I'm just doing this on the fly. I don't know if this is right or not. I don't think this is right or not. No, that's not right. And I say execute. And then let's say that I have these two hashes in here, right? And let's say these are passwords. I can take this and say something like that. Uh-oh. Oh, I use. Yes, I know. All right. Now I can take this one. Now I don't have a primary key on here, so paste that in there. All right. So now if I took from what am I doing there? Refresh that. There we go. So basically what I can do is I can take this table and I can say, and create an algorithm. I store the hash value here. I don't store the actual password here. So let's say I create a stored procedure. Let's just do it real quick here. New stored proc. And we're just gonna call this get hash dbo get hash value. And we're gonna call this at hashed val, and it's going to be varchar of 256, and we're going to say select count Now select star should be just one in there, where hash value equals hash val. And let's say I create this stored proc, right? And I come over here and I say refresh, and I say get hash value, and I say execute to. There. All right, and my hash value okay, let's say it's this one right here. So now I'm doing a password validation against the table, right? So if I do that, I get a hash value back, right? Let me go back into the procedure here. if I do that again, I should get a 1 back. There we go. And so my logic would say, if my stored prop gives me a 1 back, then I can validate that this person's password is there, right? But let's say the person is guessing what their password is, and they say, I can't remember if it's ABCD lowercase. And if it's lowercase, then it's going to be this one right here. And then I can come back over here. Now, what's going to happen is, because I used that before, it's going to be in the table. So it's keeping a string of all of the passwords that I've ever used, right? But let's say I come in here and I say my C was lowercase as well. And I run that one. You know, I just noticed something here. Previous hash. There we go. Okay. And this is my hash value right here. So now what would happen is if I bump this up against my database, it's going to tell me, nope, there's none in there like that. That will be a wrong password. So this is a perfect way to use a hash. You're not passing the actual password to and fro. You're passing the hash value of the password. It's not stored in any data anywhere. It's just passed to the database as a hash value. It's sent back as if it's there or not. That's a good way that you use hashes. So again, this video is a little longer than I thought it was going to be. If you have any questions, concerns, things that you want to talk about, add to this, leave a comment, like, share, comment, subscribe. Go check out Code Black. And until next time, as always, peace.